Now in this video we will see about the necessary conditions for the deadlock to occur. In the previous video we have seen about deadlocks and why they occur. Now for the deadlock to occur, all these four conditions must satisfy. If any of the condition does not satisfy, then deadlock does not occur. So we will see about these conditions. First condition is mutual exclusion. In the name itself you can understand mutual exclusion. So there must exist at least one resource in the system which can be used by only one process at a time. So it is implying that there must be non-shareable resources in the system. At least one non-shareable resource should be there. For example, non-shareable resource is printer, right? You can't use printer for 2-3 processes simultaneously. So there must exist at least one non-shareable resource. That is mutual exclusion. Next we will see about hold and wait. Hold, it is holding one resource. Wait, it is waiting for another resource. There must exist a process which holds some resource and waits for another resource held by some other process. So this resource allocation diagram, you see, this single dot represents single instance resource. If suppose more dots are there, then it represents that it is a multi-instance resource. That means the resource can be allocated to more processes based on number of dots. If there are 2 dots, that means the resource can be allocated to 2 processes. So here it is single dot. That means it can be allocated to only single process. Here in this diagram, process Pi is holding RB, resource RB, but it is waiting for resource RA. Process Pj is holding resource RA. So Pi is holding one resource but is waiting for another resource. This is hold and wait. Next, no preemption. We know what is preemption. Preemption is forceful exit. Once the resource has been allocated to the process, it cannot be preempted. It means resource cannot be snatched forcefully from one process and given to another process. The process must release resource voluntarily by itself. So as you can understand from the sentences, it should only voluntarily release the resource by itself. No one cannot preempt it to release the resource such that other process which requires it can use it. Until it releases voluntarily the resource, no other process can use that resource. I hope you understood it. Circular wait. All the processes must wait for the resource in a cyclic manner where the last process waits for the resource held by the first process. Now see this diagram. With this diagram, you will understand it. Here you can notice a circular loop. P1, P2, P3, P4. Directional graph. P1 waits for a resource held by process P2. See this arrow. This arrow indicates waiting. P1 is waiting for the resource held by P2. Similarly, P2 is waiting for the resource held by process P3. Similarly, P3 is waiting for the resource held by process P4. P4 is waiting for the resource held by process P1. Here, through this, you can understand that circular wait. So, all the processes are waiting for the resource. Each is depending on other, and the last process is indirectly depending on the first process. There is a loop that you can notice. So this is known as circular wait. So for the deadlock to happen, all these 4 conditions must be satisfied. Then only we can say that deadlock has occurred. If not, if any one condition does not satisfy, then there is no deadlock. I hope you understood all these conditions. Thank you.